presentation.
Hello. Okay, and hello everyone. And my name is Pin-Cheng Lai, and I'm come from the National Taiwan University. And today I'm going to present the identifying damaged native chicken carcasses for automatic grading using the deep learning. And my advisor is Dr. Yan Fuguo. And this is the outline of my presentation. And first, I will introduce the industry background and my objective. And next is the material and method. And the last is the result and conclusion. Okay, and the chicken is one of the most important species in Taiwan animal husbandry. And according to the annual statistical report in Taiwan, the 434 million chicken were produced in 2021. And the production value reached 53 billion Taiwan dollars. And it accounts for 28% of all animal production value. And you can see the chart below. The production value is growing year by year since the 2019. And next, I want to introduce the two types of the chicken, the native chicken and the broiler. And the first is the native chicken. The native chicken have the variety of breed, like this one, the red feather native chicken, and middle one, the black feather native chicken, and the golden chicken. And in the different picture, in the different breed of the native chicken, the size and color have substantial difference. And the time to raise the native chicken is 11 weeks. And the next is the broiler. And the broiler is specific raised for the meat industry. And just like the McDonald's or KFC fried chicken, the meat is the broiler, yeah. And the breed of the broiler is unitary. And they all look white, like the picture below. So the size and color is very similar. And the time to raise the broiler is 5 weeks. And my project is focused on the native chicken and not the broiler, yeah. And no matter what type of the chicken, in the slaughter process, it will face some problem. The damaged carcasses were discovered in the production line occasionally. And the main damage problem include the tear, the bruise, biopollution, and skin defection. And the main damage part include the breast, back, wing, and leg. And the reason of the damage is because the chicken will fight between each other, so it caused the bruise and the skin defection. And next, the workers is mishandling during the production process, so it caused the tears and biopollution. So to pick out these damaged carcasses, the industry used the grading system. And first, I want to introduce the existing automatic grading system. The system can grade in two parts, the weight grading and the image recognition grading. And the weight grading standard is the heavier the better. And the image recognition grading is the less damage can have the better grade. So you can see the picture below. The grade A carcass is undamaged, and the grade C carcass have the bigger torn on the breast. But the existing image recognition system is unitary standard, so it just fits for the carcass which is similar in size and color. So the system just fit for the broiler, and it is not fit for the native chicken, because the native chicken have the different variety of breed. So the size and color have substantial difference. So currently, the native chicken slaughterhouse only graded by weight. And the current approach to pick out the damaged carcass is through the manual works. And the disadvantage of the manual works is it is subjective. And next is the industry is short-handed, so it is hard to hire the new workers. And next, due to their larger body size, so the native chicken are hung by the head in the production line, like the right picture. And different from the broiler is hung by the leg. So it causes the native chicken carcass rotate on the hook. And the picture below shows the rotated problem. The native chicken can rotate in the different angles. But the existing system for broiler can only recognize the chicken at the fixed angle. So it's another reason that the native chicken is not fit for the existing system. So my objective is to use the deep learning method to replace the manual labor. And to develop a grading system for a native chicken, the system can distinguish different body parts and arbitrary angles and to identifying the damaged carcasses. And next is the material and method. And this is my system pipelines. First, I capture the image, carcass image at the production line, and next input to the two-stage deep learning model. And the first model can detect the body part of the carcass, and the second model can classify the body part is the normal or the damaged. Okay, this is the system pipeline of the two-stage model. And first, the image is input to the body part detection model and detect the body part. And then crop the body part images and input to the classification model. And the classification model will classify the body part image is the normal class or the damaged class. And the image acquisition, I set up the camera in front of the carcass in the production line and acquire 3 breeds of native chicken images, include the red feather native chicken, black feather native chicken, and golden chicken. And the shutter speed of the camera set to 1/500 second. And the image resolution is 800 to 1500 pixels. And the chicken body part detection model, I used the YOLO V4 Tiny. And the model architecture can split into 3 parts, the backbone, neck, and head. And the backbone used the modified CSP.NET53 as the feature extractor. And the neck used the feature pyramid network, FPN. It can use the different scale result from the backbone and extract the more detailed feature. And the head used the YOLO V3 head. It can predict the bounding box and category. And the data preparation for the YOLO V4 Tiny, and I acquired the 3 breeds of native chicken images. And the ratio of the data is 1:1:1. And then I manually annotate 4 categories, the wing, leg, back, and breast. And there are 450 images in total, 360 for training and 90 for test. And this is my training details. Okay, the next is the body parts damage classification model. And the model, I use the ResNet V2 101X1 BITM models. And the model parameter is pre-trained on the ImageNet 21K dataset. And the model is composed of the multiple convolutional blocks, 1 average pooling layer, 1 max pooling layer, and 1 fully connected layer. And there are 101 layers in total. And the data preparation for the ResNet model, I crop the body part image, detect from the previous model, YOLO V4 Tiny model, yeah. And I annotate it into the 2 classes, the normal class and the damaged class. And the ratio of the data is 1:1. And there are 520 images in total, and 400 for training and 120 for test. And this is my training details. And the next is the result and conclusion. And first, I want to explain what is the MAP. The MAP is the mean average precision. And MAP is an indicator of how good the object detection model is. And the result of the YOLO V4 Tiny model can achieve the 99.68% MAP. And in each class, the average precision can exceed the 99%. And this is the result of the 3 real cases. And in case 1 and case 2, the chicken is face toward to the camera in different angles. And in case 1, the chicken is front side face to the camera. And in case 2, the chicken carcass is side face to the camera. But the model can detect those carcass correctly. In case 3, there are 2 carcass in 1 frame. The first carcass is on the left and the second carcass. Yeah, but my research is expect to analyze 1 carcass in the single frame. So although there have the one wing and one leg from the another carcass, the model can still detect correctly. And the next is the result of the ResNet V2-101X1 BITM models. And the model achieved the overall accuracy of 94.17%. And the confusion matrix below, the damage class accuracy is 93%, and the normal class accuracy is 95%. And the damage class is 2% lower than the normal class. And this page shows the false negative case. And the red frame here and here is the damaged part. And you can see the left picture, the false negative case. Yeah. There is the tear on the wing, and the tear is very small. So the model recognized this picture as the normal class. But this is the damaged class, actually. Yeah. So, and the gray cam is the visualized package that can show the heat map of the model performance. And the heat map shows that the performance of this false negative case isn't very well. And the correct example should look like this, the damaged one. And this is due to the insufficient data of this situation in my data set, so the model not perform very well. And my conclusion is, we developed a grading system for 3 breeds of native chicken. And the YOLO V4 Tiny model achieved a 99.68% mean average precision for detecting body parts. And the ResNet V2-101X1 BITM model achieved a 94.17% accuracy for identifying damaged body parts. And my future work is, I want to increase the damaged body part data, like the wing image previous, and to develop a model to distinguish more categories of the native chicken. And this is the end of my presentation, and thank you for listening.
Thank you very much for nice presentation. So now let's open questions and comments. Do you have any comments or questions? Please.
How many images do you take for each of the chicken?
And yeah,
to say if it's
there are
damaged or not?
450 images in total, and I have 3 breeds, so each class is 150 images.
I understand that when the chicken is going around in the conveyor,
Yeah,
and you're classifying it if it's damaged or not, how many pictures are you taking for each chicken when you are classifying it?
each chicken classifying. You mean the second model, like the classification model?
Can you show the conveyor belt?
Sorry, can you?
The one when the chicken is hung.
Oh, is this one?
So yeah, that's moving,
Okay.
right?
It's moving. Yeah.
So when it comes to the middle here, are you taking just a picture of the chicken? Just one
I just
picture?
take one picture. Yeah, I have the sensor, and my system have image system have the sensor if the chicken go through the and
So
the sensor.
your
I take one
system
picture.
cannot see the other side of the chicken?
Yeah, my camera system I design have the 2 side images, but this one is just one side because the second camera is now just out of stock right now. So my system just have one camera right now. Yeah.
Thank you. So I was just wondering about if you can see the other side.
Yeah, thank you.
Okay, time is up. Thank you very much.
Thank you.